Hi, my name is Michael Burns. I am a graduate student at the University of Minnesota, and I am excited to share with you today my research project, Predicting Moisture Uptake with Machine Learning Models. Corn is used for a wide variety of purposes in the United States. In 2019, only 1.5% of the corn grown in the US was for food purposes. Because of this small acreage, breeders do not generally breed for traits that are specific to food-grade corn, and instead choose lines from their large germplasm pools. However, the tortilla chip industry alone is worth $20.2 billion globally, and advances in food grade corn could lead to cleaner production and better nutrition. There are a number of traits that breeders need to consider when releasing a line for food grade purposes. They need to find a line with high yield, good nutritional quality, and good cooking qualities. These cooking traits are difficult and slow to test for, so breeders often send a number of lines to manufacturers to test in a long process that is not amenable to large-scale plant breeding. A number of these traits, however, are related to one feature: moisture uptake. A masa too high in moisture will be too sticky and absorb too much oil during frying. A masa too low in moisture will not be cohesive and will not sheet properly. If breeders had a high throughput method to analyze all of their potential lines for moisture uptake in a short time frame, it would assist them in creating food grade specific lines of maize that benefit farmers, manufacturers, and consumers. With high selection pressure breeding, breeders should be able to maintain a high yielding germplasm while creating a corn plant that will be within a desired cooked moisture content range. The high throughput method we chose to pursue is machine learning coupled with near-infrared spectroscopy. We split samples into two parts. One part was cooked in a scaled down benchtop cook test shown above, while the other was scanned with a near-infrared spectrometer shown below. The moisture uptake during nixtamalization and near-infrared waveband absorbances of many samples were used to train our machine learning model. With this training done, breeders and manufacturers can quickly determine what the moisture content of their corn will be after cooking without actually cooking the kernels themselves. Our model is predicting very well, with a Spearman R value of 0.85 on samples outside of the training set. This research primarily affects the pre-production system, as it will allow breeding companies to quickly and quantitatively assess their germplasm for moisture uptake either before release or during breeding. Another system this work affects is the production system, as it allows manufacturers to determine moisture uptake at the elevator or before cooking to adjust parameters. It also affects the sustainability system, as this rapid measurement of moisture uptake lends itself to high selection pressure breeding, which can increase yield and quality to feed the growing population on shrinking viable land. I wanted to take a moment to thank PepsiCo for supporting this research, my academic institution, the University of Minnesota, and the Cereal and Grains Association for making this project and presentation possible. Thank you.